أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على رسول الكريم وعلى آله وصحبه وسلم. You are welcome to another class in the series of our lectures in this third term at the Chm2 Model College, Oyo State, Nigeria. This is the SS2 Chemistry Wk7 lecture, lesson 1 and 2, as presented by Master Ojekunle Ridwan and Master Abdul Latif Mansour. The other week, which is the first part of the topic, we talked about chlorine and its compounds. We looked at different things in the other class. We talked about the discovery and the occurrence of chlorine. We looked at the laboratory preparation of chlorine. We talked about the industrial preparation of chlorine. We looked at the physical, the chemical properties of chlorine. We also moved forward. The other class, we talked about the chemical reaction that chlorine can undergo. We looked at hydrogen chloride. After the hydrogen chloride, we look at the laboratory preparation of hydrogen chloride. We look at its industrial preparation. We also mentioned some of the physical and the chemical properties of hydrogen chloride or the hydrochloric acid. We also looked at its uses. So this week, inshallah, we shall look at the chlorides. So chlorides, what are chlorides? Chlorides, these are compounds of chlorine formed. How are they formed? They are formed when metallic ions replace the hydrogen ions in hydrochloric acid. Most of the chlorides are soluble in water, meaning that we have some that are insoluble. The insoluble ones are the copper 1 chloride, mercury 1 chloride, silver chloride. We have the lead 2 chloride. So to be insoluble, they can only be soluble when they are what? When they are warmed. Now, how do you prepare some of these chlorides in the laboratory? That takes us to laboratory preparation of chlorides. The specific method which is used for the preparation of a given chloride depends on the activity of the metal and the nature of the given chloride. Meaning that chlorides are prepared in different ways. One of the ways by which chloride can be prepared is the action of hydrochloric acid or hydrogen chloride of metals. As you can see in these equations, magnesium reacts with hydrochloric acid to give us magnesium chloride, and hydrogen gas is released. So the magnesium chloride produced is the chloride that is formed. The same thing goes for the reaction of reaction between zinc and the hydrochloric acid. Zinc chloride is formed, and we have the evolution of hydrogen chloride gas. Besides that, we also have some other anhydrous aluminum chloride that are also formed. For instance, aluminum chloride and iron 2 chloride are formed by passing dry hydrogen chloride gas over the heated metals. So these are showing series of reactions when you have action of hydrochloric acid or hydrogen chloride on metals. Moving forward, another way by which chlorides can be produced is action of the acid on the oxides, hydroxides, or triisocarbonate of metals. Like we have here, the first equation goes for the oxide. When you write calcium oxide with hydrochloric acid, we form calcium chloride, another chloride, and you have evolution of water, while water formed together with it. Secondly, here we can have the acid reacting with the hydroxide. Here we use sodium hydroxide, Roman figure 2. And then we have our sodium chloride being formed and water alongside with water. Then we have the third one, reaction of the acid with triisocarbonate, Roman figure 3. So we have our potassium chloride formed with the evolution of carbon 4 oxide. It should be noted that copper is too inactive to react with dilute hydrochloric acid. Instead, what do we use to get copper 2 chloride? Copper 2 chloride is prepared by the action of the acid on copper 2 oxide or triisocarbonate 4, as we have in this equation that follows. Acid, that is hydrochloric acid plus copper oxide, the copper 2 oxide. So we're going to have copper 2 chloride and water is formed alongside. So the third way or the third method by which chlorides can be produced is the double decomposition method. Double decomposition. What happens? Some metals, metallic lead, silver, mercury, they are also too inactive to react with dilute hydrochloric acid. Since their chlorides are insoluble, they are usually prepared by double decomposition. So it is only we should know that this double decomposition method, it is applicable to some mercury compounds, not all. Like for instance now, mercury 2 chloride cannot be prepared by this method. No, it doesn't work for mercury 2 chloride. So what works is the direct combination that we shall see as the next method of preparing chlorides. So these are equations for double decomposition. PbNO3 plus KCl, we have PbCl, then KNO3, AgNO3, NaCl plus AgCl plus the NaNO3. The fourth method is direct combination. That combination of metal with chlorine. Chlorine can react with any metal under appropriate condition to produce the respective chlorides. As you can see here, 2Fe plus 3Cl2 giving us 2FeCl3. So we have Ag plus Cl2. So in short, higher chlorides are usually produced when you have chlorine combining directly with metals. Instead of having iron 2 chloride, there is iron 3 chloride we have. We cannot have iron 2 chloride because of the oxidizing nature of chlorine, as I have established before in the previous lessons. Now, we also have mercury here. Mercury 2 chloride is formed, not mercury 1 chloride. So due to the fact that chlorine is a strong oxidizing agent. Moving forward, how can you recover chlorides from their solutions when they are present in solution? Chlorides are not decomposed by heat. Yes, they are heat labile. They are stable under hot condition. They can be recovered by evaporating their solutions to dryness. So sometimes they are also prepared from their solutions by crystallization. That is why it's one of their properties that they can withstand a lot of heat. That is why if you want to do flame test for metals, you can use their chloride to determine that. Action of it. Chlorides are used in flame tests where the metals are identified by the colors of their flames because they are not decomposed by heat. Another property of chloride is that if they react with isovaleric acid, they produce hydrogen chloride. While in the presence of a strong oxidizing agent, chlorine is produced, that is, chlorine gas is formed. How do you test for soluble chlorides? First and foremost, acidify the test solution with excess dilute triisonitrate 5 acid. This is to prevent the precipitation of other salts. And then add a few drops of silver triisonitrate 5. So a white precipitate of silver chloride which readily dissolves in aqueous ammonia indicates the presence of a chloride. This test can also be carried out with lead 2 triisonitrate 5, as you can see in these ionic equations. Silver nitrate reacting with the chloride, they are going to have silver chloride and the nitrate be separated from the solution, or lead nitrate with a chloride, we are going to have PbCl2. So this will test that chlorides are actually present in the solutions. You can use silver nitrate, you can use lead nitrate for this test. Moving forward, we will go to halogen family, but we should know that this particular lesson, which is lesson 1 of this week's work, is actually based on these things we have mentioned so far, the chlorides, how it can be prepared in the laboratory. Besides that, we look at how chloride can be prepared. The 4 ways are mentioned here. So those 4 ways, they are the most common way of preparing the chlorides. Then besides that, how we can recover them, then their properties, then how they can be tested for. Inshallah, next lesson, we'll look at the halogen family generally. Halogen family, from fluorine to chlorine to iodine to bromine to acetylene and the likes. So their chemistry and how they are what they are how we can compare their properties. I pray Allah subhanahu wa ta'ala grant us the knowledge, wisdom and understanding of what we have discussed so far. So till we meet again in the lesson 2 of this topic, I say assalamu alaikum wa rahmatullahi ta'ala wa barakatuhu.